Hello, my name is Nick, and I'm going to talk about goal programming and its use in civil engineering. Goal programming is a mathematical model used for finding an optimal solution to a complex decision-making problem, and it extends on linear programming. Unlike linear programming, goal programming can be used in a much wider range of applications because it allows for multiple goals to be considered at the same time. Let's go over a hypothetical example and show you how to use goal programming using Excel Solver. So a contractor is making a 10-year plan to figure out how many of each type of construction project they would like to try to complete. These are the decision variables that can change to optimize our solution. So looking at our goals, this is a 10-year plan, so we want to stay under 10 years. A bridge project would take roughly 4 years in duration. A building project would take 3 years, and a highway would take 2 years. The material let's say we have 100 tons of material on their yard that they would like to use up so they can use that area for something else. And they want to make it equal 100 tons. If they go under, it's going to have a penalty weighted 4, and if they go over, it's going to have a penalty weighted 12, as this would cause them to have to buy more material and bring it in. But within 10 years, they would like to use the 100 tons. So the bridge project would take 20 tons, a building would take 40 tons, and a highway would take 50 tons of material. A third goal that the contractor has is to generate at least $25 million in profits over 10 years. If this is not met, it hits a unit penalty of 12. It said that the bridge generates $4 million in profits, building 7, and highway 3. The bridge is represented by X1, the building is represented by X2, and the highway is represented by X3. For the 3 goals, the first goal is represented by D1, and then the second is D2, and D3. So let's look at the solution. So as I just mentioned, X1, X2, X3 are represented by the bridge, building, and highway, and these are the list of goals. We fill in the numbers that we just saw looking at these, and we have a -1, +1, -1, +1, -1, +1, and we use sum product of these 2 rows, these 2 rows, these 2 rows, and we also do it here. And to use Excel Solver, click the Data tab and go to Solver, and we want to set the objective to the Z value. We want to minimize this, as this represents the amount of deviation total, and we want to change these cells right here and the constraints, and then hit add, but we will cancel as we have already filled these in. We will use a simplex LP, and then we will hit solve. All constraints and optimality conditions are satisfied, so it worked. The optimal solution for the contractor is to aim at completing 1 bridge project and 2 building projects, and this minimizes the total deviation. All of the goals are met, as all of the D values are 0 except for the last one, which is the amount of profits that is under 25 million.